Hello and welcome to R&D Mathematics. In today's video, we are going to talk about vertical and horizontal asymptotes. Vertical and horizontal asymptotes. Asymptotes. Now this is related to rational functions. So let's start by recalling what we did a while ago. The graph of 1 over x. It looked like this. It had two pieces. So it's going to infinity like this. So this is our x-axis, this is y-axis. So if somebody asks you this question, is your graph, let me draw my x and y-axis in blue color. Is your graph, the green color graph, will it ever touch blue color lines? Well, actually the answer is no. It's getting closer and closer and closer. So in this graph, if whenever that happens, those lines are called asymptotes. So in this graph, the y-axis is the vertical asymptote. Y is the vertical asymptote in this graph, okay? And x-axis is the horizontal asymptote. Now, what if you had a graph like this? Let's say it can be like this. It can be, let's say, from both sides. What if your graph is doing this? So it's limiting down here to x-axis. So that's the horizontal asymptote. And this line, whatever this line, that's the vertical asymptote. Let's say the point here is B. So x equal B. That is the vertical asymptote. Now this is the simple idea behind asymptote. Now as I said, these are occurring in rational functions. Now let's see more examples. Let's see something that you can draw. How about 1 over x minus 1? So we know this is the graph of, this is 1 over x by 1 over x minus 1, cfx minus c transformations. We did these things. This will go 1 unit to the right, right? So when I say 1 unit to the right, so now see this axis, y-axis, that is where it is limited to. Now the new point would be point 1, and your whole graph will shift 1 unit to right. So this is your new graph looks like. So the asymptotes are, well, the horizontal asymptotes till this guy, which means x-axis or y equals 0. And the vertical asymptotes, remember guys, always horizontal thing is y equals, vertical something is x equal. X equal, the point is 1, so x equal 1 is the vertical asymptote. Now let's investigate a little bit more into this function. Now we learned these asymptotes by actually drawing it. Can you do this without drawing it? Well, yes, of course you can. Now this guy, let's say f of x. If you look carefully, vertical asymptote are the places where your function goes to. See, at x equal 1, we cannot say at x equal 1 because when I say f of 1, it does not exist because I am divided by 0, 1 minus 0. So when x is going to 1, when x is getting closer and closer to 1, your f value is either going to infinity or it's going to negative infinity. See, that's what's happening here. Now, if I explain this a little bit more, when I'm approaching x from left, so we write it like this. When you approach f from left, this minus sign is to say you are approaching it from left, your f of x going to negative infinity. See, it's going to negative infinity. And when I'm approaching one from right, it's going to positive infinity. So altogether, in simple words, we are looking for places where f is becoming larger and larger and going to infinity. So an easy way to find vertical asymptote is set denominator equal to 0 and then solve for it. That's going to be your, see this example, denominator is x minus 1 equals 0 and you get x equal 1. That is our vertical asymptote. Now, how about horizontal asymptote? Now, that's a little bit different story. Horizontal asymptote means, actually, if you think carefully, what's happening algebraically, like in order to algebraically explain it, well, you need the idea. So, horizontal asymptote is what is going to happen to my function when my x is getting larger and larger. So, as x goes to infinity, what happens to f of x? So that's the question. Now, how do we algebraically check this one? Now, in this example, let me investigate with this example right here. This one, as you can see, f of x is 1 over x minus 1. See, if I put f of 10,000, what's going to happen is 1 over 10,000 minus 1 is 9,999. See, this value is very close to 0. And if I make my x even bigger, what I am getting is 1 over very, very large number, which is going to 0. Right? So that's one way of finding horizontal asymptote. So y value is 0. See, horizontal asymptote is taken like that. That's the simple idea. Now let me put those things in a nice way. So vertical asymptote, write down asymptotes. Vertical asymptotes are the places where your function f of x goes to infinity or negative infinity. Horizontal asymptotes is what happens or where your function goes. What happens to f of x as x goes to infinity. So infinity comes into play. Now let's take a little bit different example and see this. Let's say you have something like this. 3x plus 7 over x plus 2. Now to find vertical asymptotes, without drawing this, to find vertical asymptotes, all you need to do, just take the denominator, x plus 2, make it equals to 0. So x equal negative 2. That is the vertical asymptote. That means, for sure you know, this graph, well at this point we don't know either it will look like this, or from here. Somehow it will never touch this x equal negative 2. That's because it's a vertical asymptote. Now, to find horizontal asymptote, so horizontal, in order to do that, what you need to do, set your check as x goes to infinity. You really need the limiting notation here, but normally we teach that in calculus. So using simple English words, we can explain this. So when x goes to infinity, what's going to happen? Now there's a little trick we can do. Let me teach you that trick. You take your f of x and denominator and numerator, I'm going to divide both of them. So let me leave some space and write it like this. And then I'm going to divide both my numerator and denominator by the highest power of my variable, and that's x in this case, so x. This will make, see, now when I divide, first term will become 3 over, no, x will cancel, 3 plus 7 over x, divide by 1 plus 2 over x. I hope you guys agree with that. Now it's easy to see what happens when my x goes to infinity. See, when my x goes to infinity, this term, nothing happens to that. But this term, 7 over infinity or 7 over large number, that terms approach to 0. And similarly, this term approach to 0. Because of that, as x goes to infinity, f of x is going to be dominated by or designed by this. It will go to be 3. So my horizontal asymptote is horizontal asymptote is y equals 3, and that is how you find that. Now let's see another example. Let me just write down some example. I just wrote it. I don't know. Let's see. Now in this case, vertical. Even without drawing vertical, well, you set your denominator to 0, x minus 1, x plus 1 equal to 0. So it's going to be x equal 1 and x equal negative 1. So we have 2 now. So at x equal 1 and at x equal negative 1. So for sure, we know your graph will not touch these two lines. We don't know how it will look like, either like this, this, or this, or this, this. It can be any way. You can check it later, but anyway, it's not going to touch their vertical asymptotes. Now to check the horizontal asymptote, you can use a graph in utility and check this. Horizontal asymptote, what you need to do, as x goes to infinity, you need to investigate this case. Now let's use my trick. You take f of x, 3x squared minus 7, and leave some space because I'm going to divide this guy by the highest term, in this case x squared. And this guy, I would actually multiply, it's already factored, so I would like to multiply x minus 1 into x plus 1, that's difference between 2 squared, that's x squared minus 1. So I divided my top and bottom, numerator and denominator, both by x squared. Once I do that, term by term, I get 3x squared over x squared minus 7 over x squared. So this will cancel, and x squared over x squared minus 1 over x squared, this will cancel. So the result is 3 minus 7 over x squared over 1 minus 1 over x squared. Now as x getting larger and larger, this term goes to 0 and this term goes to 0 again, 3. See, again, in this case, y equals 3 is the horizontal asymptote. So now we know, we can erase these things, and I can. Still, we don't know the exact shape. We have to do some work to draw the exact shape. 1, 2, 3. Now this line, let me draw solid lines. Let me use red color for horizontal asymptotes, and let me use green color for vertical. Now my graph, your graph will not touch any of these lines. So with the red color one, what will happen is either your graph going to go like this or like this, because when x is going to infinity, it's going to reach that point 3. So we don't know from which side it will appear until we actually draw the graph, but anything like that can happen, and this technique is really helpful to find those vertical and horizontal asymptotes. I think there's enough examples for those ideas. Thank you guys.